All right, in part B, we go again by inspection. We have to use, in part B, normally, the method here, the first thing is to choose which theorem, first, second, or third, because we are using or solving the same problem, have to be the third. So again, you start with EI is equally final. I am asking now to find the speed when it's halfway through, which is 15 degrees, or in the other side 15 degrees. So you can start from here, because the energy conserved anyway, the mechanical energy, or you can start from the initial point, it doesn't matter. So I can say, starting from the initial point, at the initial point, what type of energy has the object? Potential again. So it will be mgy. But what is y now? Equal. What is y? Again? mgl times 1 minus cosine theta. Same thing. Equal. At the end, when it's halfway through, I start here. When it's halfway through, does it have kinetic energy? Yes. The object has potential energy? From the lowest point is at a certain height? Yes. So you know that we have kinetic and potential. So what is the kinetic? At the second point. We are talking about the second point. Right? Plus, it has potential energy. What type of potential energy? Gravitation. And what is the formula for potential energy gravitation? This is initial, mgy final. This is the first thing you do. By inspection, you find if the object at a certain point has kinetic or has potential. Then, what is y? By definition of the pendulum, what is y? L times 1 minus cosine what angle at the beginning? At the beginning, 30 degrees. It started from 30 degrees. Equal 1/2 mv squared, and it ends at which angle? NGL 1 minus cosine of what? 15 degrees. And from there, mass cancels out. And we get from here that V is equal to the square root of 2GL 1. So if I get GL 1 minus cosine theta 30, and then if I subtract to the other side will be minus L 1 minus cosine 15 degrees. You can calculate right away, or you can see that L cancels out. If L cancels out, I will get 2G L cosine of 15 degrees minus cosine 30. The two formulas are the same. So you can see that here, if I multiply by L and I multiply by L, they will cancel out. And then if I multiply by this L, this will be negative, and negative times negative will be positive. So this interchange. And that will be the equation to find V in that case. You just substitute and you get it. Mathematically, you substitute and you get it. You can see. This is the pendulum. So now we go to the question number. This is the theory of the pendulum, pretty much, right? Question number 4, or so. Question number 3 said a pendulum is made by letting a 2-kilogram object swing at the end of a string that has a length of 1.5 meters. What is given? The length. The maximum angle the string makes with the vertical as the pendulum swings is 30. what is the speed of the object at the lowest point in its trajectory? It's the same thing. What is the only thing changing here? What I use instead of what is given? The mass, I didn't give the mass. The length I am using was what? 1 meter. And the length here, how much? 1.5, but it's pretty much the same problem, right? I just, by mistake, put the same angle. All this. But anyway, this is the solution of number 3. Number 4. A 2 kilogram mass swings at the end of a light string. Length 3 meters. Its speed at the lowest point on its circular path is 6 meters per second. The question is, what is the kinetic energy at an instant when the string makes an angle of 50 degrees with the vertical? So now, instead of the velocity or the speed, I want the kinetic energy. So you don't have to even to substitute this formula. So if you will go, tell me, you will use CI is equally final because there is no friction. From the content of the question, where the object starts, having lowest point. So at the lowest point, what type of energy will have the object? Kinetic. So what you will write? Is given the speed?
Yes.
It's given the speed explicitly, so I can find 1/2 mv squared at the lowest point. Does it have kinetic energy? Potential energy? No. Plus 0, because doesn't have, it's at the lowest point. It goes, the question is, what is the kinetic energy at an instant when the string makes an angle of 50 degrees with the vertical? We go now to inspect the final moment. Does it have kinetic energy? What we are looking for? They ask, what is its kinetic energy at the instant when the string makes an angle of 50 degrees with the vertical? Does it have kinetic energy?
Yes.
And that's what you are looking for?
Yeah.
Do you need to substitute by 1/2 mv squared? You just put kinetic energy final. Plus,
Potential.
does it have potential energy?
Yes.
What is the formula for the potential energy?
MG.
mgy. And what is y in this case?
Yeah.
So can you see that it's pretty much the same? So this is the pendulum. You have other pendulum questions there, probably. Question number 6, which is similar to the pendulum. It's a ramp, but works the same way than the pendulum. Question number 6. Question number 7 doesn't work the same way. It's a projectile motion question, but you can answer that projectile motion from energy perspective. At the beginning, that projectile motion question, number 5. Tell me, a 0.04 kilogram ball, 40 grams, is thrown from the top of a 30-meter tall building, point A, at an unknown angle above the horizontal, as shown in the figure. The ball attains a maximum height of 10 meters above the top of the building before striking the ground at point B. Air resistance is negligible. The question, what is the value of the kinetic energy of the ball at B minus the kinetic energy of the ball at A? So we cannot solve this from a projectile motion perspective because they didn't give the initial angle. You remember